This chapter requires some knowledge from Chapter 4. Welcome to a basic concept of linear transformation. In order to understand the concept of linear transformation, it is important for you to know the definition of every term used in this topic. T is called a linear transformation if each function w is a linear function. The image is another term used in this chapter. If each vector in V maps into one and only one vector in W called the image. Now, let's look at the definition of the range of T. The set of all images is called the range of T. If a linear transformation, T maps from a vector V into a vector W, then V will be said to be the domain of T, while W is the codomain of T. Here is a simple question to test your understanding. Let's say you are given this transformation. Determine the domain of the transformation. You're right, this is the domain of T. How about the codomain of T? Excellent. This is the codomain of T. Next is the most important in this chapter. It is a standard matrix. Based on the transformation, a matrix A is a standard matrix with size of m by n. Here are the examples of the transformation and its standard matrix. How to obtain a matrix representation of a linear transformation. The first step is identifying the size of the standard matrix, A. The dimension of the domain will become the number of column of a standard matrix, A, whereas, the dimension of the codomain becoming the total number of row in matrix A. On the second step, the standard matrix will be obtained. All equations will be labeled as W1 and W2. We can see that all of the variables are arranged in the same column. Refer to X and Y. Then all of the coefficients will be assigned into a matrix to form a standard matrix, A. Finally, the last step is to convert the transformation, T, into a matrix form. By using the standard matrix obtained from the previous step, substitute matrix A into the equation, T, X, equal to W, equal to a standard matrix A, X. There are two conditions need to be satisfied by a transformation to be a linear transformation. Let's look at the example. Based on the first condition, we are going to look at the left-hand side first. What we going to do are to add up these two matrices and do the transformation process based on the transformation given from the question. Then, we are going to proceed with the right-hand side. On the right-hand side, we will transform both matrices first by following the transformation given, and later add up both the results. As a conclusion, we found that the result obtained for the left-hand side and the right-hand side is similar. The same process will be used for the second condition. We are going to look at the left-hand side first. A constant will be multiplied to a matrix, and next will be transformed by following the transformation given. On the right-hand side, we will transform the matrix first and next multiply the result obtained with a constant. Hence, the result obtained for the left-hand side and the right-hand side is similar. Thus, condition 2, also satisfied. Therefore, we can conclude that T is a linear transformation since it satisfies both conditions. That's all. Thank you for watching and hopefully this will help you to understand on the basic concept of linear transformation. Till we meet again.
Created using Powtoon.